It was going guys, Communications here, so I continue testing my 8052 basic computer with a 52 basic interpreter. So here I found a documentation finally for this, so yeah, it can do a really lot of things. I didn't even think that it's that powerful basically. So in this video, we're gonna be playing around with inspecting the external memory and trying to write something to that memory. And the reason for doing that, because if you're using the standard array syntax definitions, you're limited to only 254 elements per array, which might not be enough in some cases, but using this XBY, which works both for read and write the external memory, which I do have on my computer by Dominic Bumbaca. So yeah, I can make use of this in order to just use my data memory however I want within the entire range of what is available there. Okay, so I will now plug in the computer. So here we go. So it's now live. And well, probably let's start by single instructions. So let's say print x, b, y, and let's say 0. So what is available at the element index 0 in the external memory? So we have some value there. Now here are a few tricks that I personally really love about this basic that I didn't know they exist. But anyway, so for me personally, it's much more convenient to work with hexadecimal values rather than decimals. So we can use them for both to input the data via input, via source code, and to output the data as the hexadecimal to the output to the console as well. So for instance, if I want to say print XBY and let's say 1024, right? And there is the value of 0. Okay, but if I want to input this value in hexadecimal, I can simply say print XBY and then 400 hexadecimal, and I have exactly the same result. Now, for instance, if I want to output the 512, for instance, I can say print and XBY 512 is going to be 200 in hexadecimal, right? So we have one there. So okay, and another trick, so we can do we can output in the hexadecimal as well. So in this case, I need to say print hexadecimal 0 suppression and dot here, that's the syntax, and then XBY and for instance the same 40 hexadecimal, and here we go, we have this 00 hexadecimal, which is fantastic. Now for instance, let's try to print what this value in hexadecimal, because it's kind of bigger than 1, so yeah, it kind of makes sense. So for instance, we can say ph0 dot and xby 0, and now what have I done? Sorry. So ph0 xby 0. I may leave it as is, or I might add the hexadecimal, doesn't matter. And here I have the fb value in hexadecimal, which is 251, being converted from decimal to hexadecimal, which is extremely convenient thing to consider. So what we can do now, basically, so we write a simple program. So for instance, let's say 4x, 10, so 4x equals 0 hexadecimal to, if I have the hexadecimal address, I need to start with 0, that's the syntax. So for instance, f hexadecimal, right? And here I want to print hexadecimal without zeros, and I want to print, say, address itself, which is x, the index, and then followed by xby, so whatever is available at that memory address, like this, and then 30. I can simply say next x, and let's list the program, right? So if I now run this, it actually, what's run? ph0x xbyx. Okay, so it doesn't like Oh, there should be a semicolon. It's not Python, I'm sorry guys. Okay, so 10, yeah, it's not Python definitely, equals to 0h to 0f, whatever then, again, 10 for x equals 0h to 0ffffh. Try again. Okay, now we go through all of the memory addresses, but it obviously takes kind of too long. So is there a way to allow the user inspect only those memory addresses he's interested in? Well, definitely that is. So we can stop this by pressing Ctrl+C. And now we can make some adjustments to our program basically. So for instance, I can say the following thing. So let's start from line number 1. So I can say here, for instance, let's say print, and let's go for a start address. So we ask user to input the start address, then we say input and store it to variable a, and then want prompt the user to enter the end address, and then store it input b, right? And yeah, let's list the entire program. Okay, so now in the line number 10 we can say, instead of what we have there, we can say for x equals to, starting from a where the user stated the starting address, to b. And that's pretty much all about it basically. So let's list again. And if I did everything properly, now user can specify the source and target address to inspect memory within that range. Alright, so now let's actually give it a try. So if I run the program, so I'm asked for the starting address, so I can input this either in decimal or in hexadecimal. So for instance, I want to say from this address, so 10 for the 1024, and up to 1K of memory to this one, right? And I do have that. Well, I'm still having the addresses obviously been printed as hexadecimal because that's just the more convenient way of doing things. But okay, so it does it seems like, okay, hold on a sec, yeah, it does exactly what it has been asked for. But what is even more interesting, so we're just trying to run this again. Then basically we can say from, let's say 400 hexadecimal to, let's just have kind of sum, so only 15 values like this, for instance. And here we go, we get only 15 values we're interested in. And now you see, like, every time it has executed, actually drops back to the basic console. So this might be, so if I just list again, so this might be slightly altered. So for instance, we can say 40 and we can simply say go to 1. And in this case, so we list again, in this case, this program is going to be running forever until Ctrl+C is pressed. So let's have a look how this works. So I say run here, and let's say 200 hexadecimal to, oh no, it's not, it's wrong, it's 200s in decimal. Okay, it's wrong, sorry. So let's say 200s hexadecimal to 20f hexadecimal like this. Okay, and now you see, like, it drops back, so it just starts the program from the beginning. So now I can say, so 400s hexadecimal to 40f hexadecimal, and it brings it here. So now let's see what's the range basically. So for instance, if I want to say the starting address from 0 f0, I'm starting with the 0 because that's the requirement for the syntax. So it recognizes the hex string basically. it's handled by the BASIC automatically, which is fantastic. And the end address, let's say 0FFFF hexadecimal. So yeah, here we go. And you might be wondering, is there something above? Well, I guess not, but let's actually figure this out. So if I say again, so 0F, that's not, so 0FFF0 hexadecimal, okay, and the end address 10000 hexadecimal, like this. And yeah, I'm not sure why it's okay. Let me just restore the program again. 0FFF0 hexadecimal, okay, and the end address 10000 hexadecimal. Well, it's a bit strange. Well, it's okay that it can't actually show anything there, because probably that memory location just simply doesn't exist. But I'm just wondering why it gives an error within the input routine itself. So it just intercepts the input routine for some unknown reason to me. If I say 0FFFF hexadecimal plus 01 hexadecimal, for instance, like this. Okay, extra ignored. Yeah, so now I did actually manage to go one step above, but whatever is not available, it just gives this extra ignored. Well, not sure whether this is an error or just a warning. So it just ignores whatever it just can't show you, and that's pretty kind of clear. Okay, so what we get so far, we have a program that does this in a sort of a never-ending mode, but also it would be convenient to actually have an option for a user to kind of input the data to those particular locations. So let's try that as well. So what I want to do now here, so 40, I just want to say AND, so it just drops there, and then let's say 50 print let's say new prog here, so just to make sure that it doesn't go there ever. So let's list again. So it should execute until here and then not print this one. So let's try to, we can either run, or we can actually say go to 1, which would do exactly the same trick. So here we can say, yeah, so like say 0, like to 10, for instance, and we've dropped here, and you see like it didn't actually print this one, because it just goes after the end occurs. So if I say, for instance, go to 50, then it does print this new prog, okay, and then it drops again. So here, starting from the line 50, we can draft another program that would be capable of like putting some values, putting some data into the memory. So for instance, I can say 50 print, let's say input format, and yeah, so one more time, 50 print input format, and so we say address and value, like this, and then 60. I can simply say input, and so A and B are taken. So for instance, A, B, like let's say C and D, all right. And then 70, we want to say let XBY indexed by C, which is address, is equal to D, which is data, right? And then actually, to make sure that we did input this data, we can actually go to so here we already have this. So let's actually set up the A and B. So let's do the following thing. Okay, so let's say nope, 80 80. Let A equals to C, which is the starting address, right? And 90, let's say let B, the end address, is equal to A plus 10. So want to have like 10 elements more after. And then 100s, want to go to the place where it actually prints the routine, and it's 10 basically. So go to 10. Okay, and let's list the whole program now. Okay, what's wrong with this 8? Sorry. List again. Yeah, that was my fault. Okay, so if we go here, then we would be asked to actually input some data, right? And then we should put this data to add whatever address to put whatever data we want. Then A, which keeps track of the starting address to print, should be assigned to the C, the value of where we're supposed to be writing our data to. And then B, the end address is going to be A plus 10, so we want to write up to 10 elements. And then we go to 10, so we go to here, right? And we then print that chunk of memory that we've just written some data to, like the very first element, obviously. And we do skip this part. We do skip this part because in this case we don't actually want to we don't want the user to do this manually. So if I now did everything properly, what it should do at the very end, it actually should. So if I say go to N50, it would ask me to input the data. Actually, this should be the capital letter, but anyway, the uppercase. And then, yeah, so let's start by, let's say, go to 1. And we're going to be writing at, for instance, 400s hexadecimal. And the end address 40F hexadecimal. It's not 10, it's 15, but anyway. So yeah, we have all zeros here. Okay, and now again list. Now we have this 150. So I say go to 50. So input format, address and value. So the address 400 is hexadecimal, and the data I want to put there. Let's say DE. Yeah, it's just not gonna be working like this. Yes, I'm sorry. 0 starts from 0, so 400 hexadecimal, 0 DE, and hexadecimal. Okay, and you see, like, we've just written this value at this address. So far, so good. So we just say go to, and actually, yeah, now you see, like, I say this go to 50 manually. So I can make another go-to that would be doing this like forever, basically, which might make some sense. But for now, yeah, let's actually drop it as is. So now let's say 401 hexadecimal and the value 0 AD hexadecimal, like this, for instance. Okay. Oh yeah, now it just starts from, now it starts from actually the next one that we were about to be doing. So maybe I should have altered this to just to see all of the, it kind of scrolls now. So yeah, let's adjust the code a little bit. So I want to let's actually make it like 80. We'll say let A equals C, maybe -5. Let's make it like this. And 90, let B equals, for instance, C plus 5. Okay, and now, yes, list again. So now we can go back to, like, go to 50. And here, for instance, so we had, yeah, now we go 0, 4, 2 hexadecimal. And let's give this value. Okay, so it starts from, okay, this was the input. And hold on a sec, I'm just wondering, what has happened to memory? It just, hold on a sec, I'm wondering why it doesn't have any values there. So if I just, this is a bit strange, so go to 1, 400 hexadecimal, and 40F. Okay, yeah, this is a little bit strange. So where that gone, basically, where that has gone. Okay, let's go back, go to 50 again. So if I say 400 hexadecimal, 0 DE hexadecimal. Okay, hold on a sec. Okay, this is here. Okay, this is it. So here it just prints the line that I just did input. Here it prints, yeah. Here it prints. Might not, the offset might not be perfect, but I just want to see the entire data. Well, actually, might not be that necessarily needed, but anyway. Okay, go to 50 and like this, and another value here. Okay, and now it seems like all three values are there. So go to 50 and Z403 hexadecimal. Yeah, probably because I've altered the source code. Maybe that's the reason why it just got erased. I'm not sure, it might not be the case, but anyway. And here 0FFH. Nope. A bit wrong. So I wanted to say go to 50. Like this. Hexadecimal. Okay, and we got that beef here. Fantastic. So yeah, as we can see here, we actually can write the values to the external memory, which is fantastic. And now just the very last thing before I go, just to give an idea why this might be kind of beneficial. It obviously it shouldn't be done just from this user input string. You can do this from code as well. I just want to make sure if this actually, so if I just say I will now try, let's say, put FF here from code now. So let's try that as well. So if I can say let x be y 405 hexadecimal is equal to 0FF hexadecimal, and now go to 1. And so starting from 400 hexadecimal and to here, and indeed you see, like, yeah, we start from here, so here's our dead beef, and here we have this custom FF being kind of flashed there from the code. So yeah, it also works from the code. Obviously it works from the code. And yeah, this is really handy. So yeah, and now just like I promised. So why do we want to do it like this? Because you might be wondering why not to use the arrays. Well, here is the deal. So for instance, if I want to define the array, so dim stands for dimension, if I'm not mistaken. Dim, let's say, I don't know, Q for instance, and it would be. We can also specify this in hexadecimal or in decimal. So let's specify in hexadecimal like this, you see like it gives the error size. So the FE is the smallest, is the biggest values. If I say like dim Q and 0FE hexadecimal, still doesn't work. You must be kidding. Dim Q 0F. Dim Q 0F. A, B, C, F, D, maybe. It's a bit strange. Well, this works. Oh, it stopped working with the decimal. Am I doing something wrong with the syntax? Okay, sorry. Something is going horribly wrong here. Is my program still alive? Yeah, I just want to save this for the future generations on my GitHub. Okay. Yes, something. Maybe, hold on a sec, let me just go 110 and say let, no, not let, 110 dim Q 254. And go to 110. Okay, so yeah, probably can do this only within the code, if I'm not mistaken. And now I probably can print this Q array, print Q, oh, or size. So probably it's, yeah, still probably should be referenced within the code. So let's go 120 and try to print Q and yes, list again. Yeah, let's go to 110. So go to, yeah, and there we have the value of 0. So yeah, now it should be just as line numbers. It doesn't go in in the direct mode. Okay, so far so good. But here is the deal. So here, for instance, if I say the same dim Q, but in hexadecimal now, so 0F, let's try FF. This probably doesn't work. Go to 110. Yes, array size. So 110 dim Q 0F E. So this should be the equivalent of 254, obviously. So 110. Yeah, now works. So if we exhaust, if we exceed the value of 254 or FE hexadecimal, in this case, it just gives an error because it doesn't support bigger arrays bigger than 254. But if we're using this fantastic XBY, which reads or assigns the value of the external data memory, in this case, we can have a whole lot of like variables per program, which kind of widens the opportunities, the options that we have when we're writing our programs in BASIC. So yeah, I think that's it from my side, guys. So I hope you've enjoyed this tutorial. Well, at very least, I've enjoyed playing around with this fantastic 8052 BASIC computer so much. So I've been doing this for an entire day, and I've just shown you a very tiny, small part of that. So that was real fun. So if you're ever about to try this, you definitely never forget this experience, because this is so exciting. This is it from my side. Thanks for watching. Until next time, and take care.